Then we are going to graph rational functions. So I'm going to show you its parent function, okay? Its parent function is 1 over x. Okay, y equals 1 over x. Now, I don't know if any of you guys have graphed this before. If you haven't, what do you do when you don't know what a graph looks like? Plug what in? No! Jump to right technology? What if they didn't have technology? Don't give me that look back there, Miss Ford. What do? You don't know what it looks like. Isn't a graph a collection of points so close together they touch? Yes. So we just start picking values. Okay, so I'm going to pick, first off, -1. I'm going to pick -2. I'm also going to pick a half, -1/2. I'll show you why. And I'm going to pick 0. I'm going to pick a half, 1 and 2 as well. Everybody there with me? Once again, it's just a plug and chug, correct? So what is 1 over -2? -1/2. What's 1 over -1? What's 1 over -1/2? -2. Cut one pizza, cut it in half, with 2 people to eat. That's how I think about it. If not, 1 divided by a half is the same thing as timing by the second guy's reciprocal. 1 divided by 0, undefined. 1 divided by a half, 2, 1 1/2. Any questions on where I got those values from? I'm going to introduce some things as well. Okay? So here is the parent function. Just like the x squared, parent function is a parabola, and then we adjusted the parabola, correct? We're going to do that same thing today. We're going to adjust a rational function, and I'm also going to teach you other ways to do it as well. Okay, does that make sense? Did you bring me my half? Thank you. Ladies and gentlemen, it looks like. Can you see that? Now, why will it never touch the axis? Because I can't plug x equals 0, right? Because if I plug x as 0, it's, undefined. How many of you guys have ever heard of the word asymptote? Asymptote. Asymptote is a value that you cannot be, or that you're going to approach but never touch. Okay? Now that's if it's a vertical asymptote. Our vertical asymptote is 0, because we cannot be 0, right? Does that make sense to everyone? Do I need to scooch it up for you? Jed, you okay? The value you cannot be. Now, why does it get really tight against it? Because could I use -1/3? What's 1 divided by -3? -1/3. -3. What's 1 divided by -4? 4. -4, right? What's 1 divided by -1,000,000? -1,000,000. It'll grow. I can get up to 0. I can use -0.0000000000001, and I'll be okay with that, right? But if I do 1 divided by that, that's a large number, isn't it? Hence why it drops, correct? Does that make sense to everybody? Austin does. He's the one first. I see some shaking heads. We okay? All right. Now, let's talk about how we would write domain. Okay? This is how I prefer it, but it's not the way the computer does it. So, I'll show you both ways. Domain. What numbers of x can I use? Everything except for 0. So this is how you would write it. I can use -infinity up to 0, right? I did not put a bracket because I cannot use 0, can I? What other numbers can I use? Anywhere from 0 to infinity. Say again, I'm sorry. You got to have the union in between. Now what the book would probably say is x such that, might do this, x cannot equal 0. Or it might just say x can equal 0. I don't know. It's going to put something x can equal 0. We might have to look online if we have time. Okay? We might pick some other people, maybe Miss Tonks, because I'd have to register her. Okay. But it's not this. This is really, to be honest, I don't know why more books don't go this way. This is what's used later. I don't know why they just don't put it in that way. Okay? Now, what's our range? What number is y not touching? Why can we never be 0? Because 1 divided by what number will ever give me a 0? 1 divided by 0 is undefined. So that is not. Okay, 1 divided by what number will ever give me 0? There's nothing. When do fractions become 0? When the numerator is 0. If 1's already on top, I can never make that 1 a 0, can I? So hence why this graph will not touch 0 for the y, or the horizontal. Does that make sense? You with me on that? Because 1 divided by any number is going to be some kind of number. Okay? Now if I had an x value, say let's say x over 2, what value would make that 0? 0 would make that 0. If there's a variable there, there's a possibility of making it 0, correct? Does that make sense? See what we're trying to get at there? Okay? So therefore I'd cross. But right now my range, once again, would be negative infinity to 0. I don't know what that is. Union 0 to infinity as well. It goes up to 0, jumps, goes up again. Always range is lowest to highest, lowest to highest. Range is always least to greatest. I'll be telling you what I've seen on some of your guys' tests. That's why you miss domain and range a lot. It's because you're going highest to greatest. If you go infinity to negative infinity, which is not correct. Why? She's spruce. Why aren't you guys spruce? Good on you. Good on you. She's all dressed up. Maybe she takes the one knee approach and kisses the butt. So what do you guys think? This says right here x minus h. What do you guys think that minus h does? Moves it right and left, just like we did previously, right? What do you think the k does? Moves me up and down. What do you think the a does? Stretches me. So instead of here, or like, come on. You can't do that graph. You get what I'm saying. But I want to do it with my body. No. There is a way to do it. I can't think about it. I've seen a shirt. Anyway. Awesome. Da, 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 da. Imperial. You guys know where that came from? A margarine commercial. Back in the day, the guy would wear a hat, brown. Imperial. Okay, let's go do this one. I'm going to draw my axes here really quick. Alright? It says, what is the graph y equals 12x? What is the graph? Okay, so once again, we kind of don't know, but what number can we not be again? X cannot be 0, right? So that answers this question right there. X cannot equal 0. At x equals 0, that is an asymptote, right? So what I do is I do a dotted line. Saying, I can't touch him. Because it's not always going to be at 0. It might move, correct? Everybody with me on that? Okay. So it says identify the x and y intercepts. X-intercept is when y is 0, right? X-intercept, y is 0. So if I plug 0 in for y, I get 0 equals 12 over x. What do we get? Times the x over. Does 0 ever equal 12? So is there such thing as a y-intercept? Why is there no such thing as a y-intercept? Because I can't be here. So that is a vertical asymptote as x equals 0, and that's on my y-axis, right? Okay, can my graph ever be? Let's find our y-intercept. Y-intercept is when what? X is 0. Let's try that guy. Okay, so we say, oh, okay, y equals 12 over 0. Oh, no, I just blew up the world. That's what I think of. Why are you mocking me, Bethany? It was great, though. Did you like that? I did, too. Good luck in your swim today. Swim hard, pull fast. Oh, I'm getting old. Hey, so then I can I plug 1 in? What's 1 divided by 12 divided by 1? So I'm going to go by 2. So that's a 2, 4, 6, 8, 10, 12. Can I put in 2? That'd be 6. 2, 4, 6. Can I do 3? 4. Can I do 4? 3. Can I do 5? Yeah, I don't want to. Can I do 6? You guys see it going down, right? It goes like... It's going to get there because I'm decreasing. You guys can see it's getting smaller and smaller, right? Will it ever touch 0? So we just proved it, right? We couldn't do that. We tried to find our x-intercepts, didn't we? Okay? Can I pick -1? Yeah, I can -12. -6. -4. -3. -2. Like that. Okay. Well, no. That's the easy one. That's our parent question. Okay, so what are the x and y intercepts? We don't have any. What are our asymptotes? What's my vertical asymptote? X equals 0, right? Vertical, down. X cannot be 0. What's our horizontal asymptote? Y cannot be 0. Did you see that? X cannot be 0. Y cannot be 0. We'll never touch those, will they? So hence they're an asymptote. Notice an asymptote is also end behavior. You will always approach your asymptote in the end behavior. So as we go to infinity, we will approach y equals 0. You'll get so close to 0 it looks like it's touching it, but it is not. Just think about it. What's 12 divided by 1,000,000? Very small number, isn't it? What's 12 divided by 1,000,000,000? Even smaller. You get what I'm saying? It's going to get there, but will it ever be 0? No. Does that make sense to you guys? You will always approach them in the long run. Okay? Yes, no, maybe so? Okay. What is the domain? No, Betsy. No, Betsy. Our domain is -infinity to 0. Union that with. Is it always going to be this? No. What's our range? Ditto. I don't want to write it. It's the same thing. Making sure we know that. So would the function 6 over x, 8 over x, and 12 over x have different domains? What number can they all not be? They can't be 0, so they all have the same domains. Will they have the same ranges? Still the same ranges. Because I still will approach 0 both ways. I can't touch them. All that does is stretches them, makes it go faster, right? That's all it does. Does that make sense what I'm saying? Obviously 12 grows faster than 8 does, than 6 does. Make sense? Okay, next one. Okay, so it says, each part of a graph, a reciprocal function, is called a branch. The branches are typically in quadrant 1 and 3, as we've noticed. Why are they always in 1 and 3, as of right now? Because when we go, Tyler, you said it, and so did Michael, but whoever wants to go with it. Go ahead. Why though? Because the x values in quadrant 1 are positive, right? And the x values in quadrant 3 are negative, hence why the graph's there, because we have a positive number divided by positive, hence it would be a positive. What if it becomes, instead of 1 over x, it becomes negative 1 over x? What quadrants would I be in? I'd be in 2 and 4, right? Because a negative number over a positive would put me down something like that. Does that make sense? Because we flip it, right? Remember this? If it was a negative, flips me down. So you get to say what I'm trying. Yeah. Whatever. You get what I'm saying? It flips me, right? So therefore, he was down here will flip up here. Because a negative number divided by a negative will become a positive and vice versa. We kind of already did this. Notice when we plug this in here, what does that a value do on our graph? It just stretches. I really don't care about that too much, to be honest with you. But I do care about this one. So what do you guys think is going to happen on this guy? Just talk to me about it. We're just going to sketch it. We're not even going to use real points. We're sketching this stuff. Up 6. So what's going to be my, okay, maybe I should ask you guys this. What's going to be my vertical asymptote? Positive 4. I could not be 4, right? I could be negative 4, right? I couldn't be 4. So I'm going to draw my axes here. I'm going to draw it a little bit lower. Okay. So, once again, as everybody said, the number we cannot be is 4. So, 1, 2, 3, 4. I draw a value. Does that make sense to everyone? Yes, no? Tonks, you okay? Jessica? Tanner, you okay? Chad, you good? Michael Paletta? Okay, what is the 6 going to do to us? Up 6. So what number are we not going to be able to do now? Notice beforehand we couldn't be 0. Notice this is a fraction plus 6. The only way to ever touch 6 is if this guy will ever be 0, right? Will 1 divided by anything ever be 0? So hence it makes sense that I will never touch 6, because that's the only way I can get there, is that if this fraction became 0, correct? Does that make sense to everybody? Right? And then, notice, is it positive on top or negative on top? So what quadrant should I be in? 1 and 3 still, and I'm just sketching it. It kind of goes like this, and it kind of goes like that. Could I get an actual x-intercept? Am I crossing the x-axis? Am I crossing the y-axis this time? Could I find an x and y-intercept this time? Sure, should we do that? What the crikey, right? What the heck? Let's give it a shot. So let's go ahead and find our y-intercept, because that's usually a lot easier to find. So we plug in what for 0? 0 for what? X or y for a y-intercept? 0 for x. So I have 1 over negative 4 plus 6, so that's basically 5 and 3/4. Does this tail down, by the way? Sorry. Does this tail down? Come up more like that, right? I apologize. That's doesn't. It gets closer and closer to that 6, doesn't it? Does that make sense to everyone?
Yeah.
And does it look like I'm crossing at 5 3/4, roughly? Should we try our other guy? Notice I don't like that, but I'm just kind of doing it really quick. X-intercept is when y is 0. So we subtract the 6, or let me show you a different way. This is kind of more, we'll do both. So we subtract the 6. Any questions? Times the x minus 4 over. Does that make sense? Just multiplied it through. Subtract the 24. Oh. Thanks for the dirty look. So x is 23/6, which is right before 4, right? Everybody see how it's right before 4?
Yeah.
Does that graph look like he's crossing right before 4? Does, doesn't it? Reasonable sense. Let me show you another way really quick. Can I come back to this stage right here? I'm going to show you a different way. We'll do it in red over here. Do the common denominator for me really quick, please. So I have 1 over x minus 4 plus 6x minus 24 over x minus 4. What does the top become? Now, like I said, when does a fraction become 0? When the numerator is 0. So basically, don't I just set the numerator equal to 0 and the plus on my 23 over 6? Different way to see it, right? So when they are in that way, that's maybe something to say. Put that in your notes. Remember, if I have a common denominator, and I've simplified the fractions, the numerator will always be my x-intercepts. Once again, it needs to be a simplified fraction. Notice we had 2 numbers beforehand, and we combined them to a simplified fraction, correct? When you have that simplified fraction, the numerator will be your x-intercepts. Okay? So notice when we had 1 over x, can 1 ever equal 0? No, hence why there was no x-intercept, correct? Does that make sense to everybody? Does everybody see how this guy can be 23/6? So we add the 23 divided by 6, correct? We're doing okay? That was just a basic sketch. And to be honest, on rationals, that's really what I'm looking for, is basic sketches. The things I want you to know for sure is your vertical asymptotes and your horizontal asymptotes. Okay, those are for sure things. Does that make sense to everyone? Okay, how are we doing time? I think we're going to look back up here and also talk about domain and range really quick. Identify the domain and range. Okay, so what is my domain? Everybody try to write it on your own first. Let's have everybody try to write it on their own. See if you There you go. The class wants to promote the event by giving away 30 spots to students in drawing. How does the model change? So now we subtract that. So now the number of students paying goes from anywhere from 0 to 82. So how many students, once again, now needs to be so that no more than $750. How many paying students? Again, it's about the same, right? Still need 160 students, even if we're doing that. I don't know how that's great. I don't watch it. It's not too bad. Yes! Holes! Love me some holes. I gotta read these before I teach them. That might be helpful. I'm busy. functions in the form like x plus 3 over x plus 16. Can we graph this one? That's the one I want to graph. I'm excited for that graph. This is the one I'm excited about. Because this is more traditionally what we've done in the past. So what you need to know and understand here is what value of x can we not be again? What number? Negative 16. Does everybody understand why negative 16? Yes, no? That's my asymptote. X cannot be that number, so I have to draw a vertical asymptote. Yes, no, maybe so. How are we looking? Okay, with that being said, here's the next thing that you haven't done. If I did long division, okay, just looking at that, if I did long division, what would that come out to be? I don't care about the remainder. What would that come out to be? Say it. You got it. 1. Because we'd look at x plus 3 on the inside and x plus 16 on the outside, and we'd say, how does x become x, right? That becomes a 1. Okay? So notice the horizontal, and let me explain this. Okay, who's going to take over, the 3 or the 16? Excuse me, the 3 or the x? Who's going to soon take over? The x does, meaning the x tells us what it's going to be depending on what the values are, right? If not, it'd just be consistently 3, but because we're adjusting the x's, it changes and it's kind of like a line, right? Does that make sense what I'm saying? Who takes over, the x or the 16 on the bottom? The x does, right? So what you do is, well, all we got to look at is here. Divide. What does then x divided by x come to look like? 1. It's going to sooner or later, my horizontal asymptote is going to be 1. Let me go back a couple slides. Look down at this guy. What was my horizontal asymptote? It was 6, right? Notice because of this plus 6 here, huh? Everybody see that? But remember when I put it in a fraction? It was 6x minus 23 divided by x minus 4. If I did long division, what does that come out to be? You can find your horizontal asymptote by doing long division. You can find your horizontal asymptote by doing long division. Nope. Does that make sense to everyone? So, looking here, I know I will not... Okay, can you cross one? Yes. You can cross a horizontal, by the way. You can. Okay? What did I tell you also about a horizontal? In the end, what will it approach? It'll approach the asymptote, won't it? So sometimes, just to give you a little idea, I'm going to draw this really quick. This is what your graph would look like sometimes. In the end, where is he coming to be? He comes maybe back up. And sometimes that happens. Not in this case it doesn't, but I'm just suggesting it can cross a horizontal. In the end, as we go, it will approach 1. The end behavior will always approach your horizontal asymptote. I've only usually seen it 1, but I bet it could. But can it cross a vertical asymptote? Why? What's the difference? Those are the values x cannot be, so I can't even plug stuff in for that. Does that make sense what I'm saying? Okay, so coming back, that's a bad sketch, so I'm going to get rid of that. So I do my undo button. Okay, so now I'm going to graph this thing. Okay, so what you do, let me show you how I pick a graph. Because we need to understand whether it's up here, down here, down here. Okay? So just pick a value greater than your asymptote. Give me any number bigger than negative 16. Negative 5, negative 15. I like 0. Because if I plug 0 in, look where it crosses. Where does it cross at? Notice that means it's down here. 3/16, there's like 16 right down there. Look. Right? Okay? What if we plug negative 15 in? Let's actually find our x-intercept. I guess I should have did that. I'm really crazy today. Let's start over. I apologize. Okay, let me also find my x-intercept. That actually is something as well. What would be our x-intercept, Mr. Daniels? You know? Or did I tell you guys first? Huh? Get x-intercept. Where do we find the x-intercept at? When the numerator is 0. What value gives me the numerator 0? Negative 3, right? So it crosses right there. Okay? So what we do is we pick some values. This is how I was taught to graph. You just try to do this little chart. We put important values here. My important values are my x-intercept, which is negative 3, and then I pick my vertical asymptote, which is negative 16, meaning I cannot be here. This means when it is 0. Does that make sense? Okay, when we picked a number greater than negative 3, which was what again? What did we get? Did we get a positive number or a negative number? Came out to be positive because it was 3/16, right? So I put a plus. Let's pick a number in between these two. Negative 8. When I plug that in, what's negative 8 plus 3? Just tell me positive or negative. Negative. What's negative 8 plus 16? Positive or negative? Positive. What's a negative divided by a positive? All I care about is that that's negative. I'll explain how I'm going to use this chart in just 1 second. Okay? Give me a number past negative 16. Negative 20. Okay? So when I plug that into Cole, what's negative 20 plus 3? Just tell me positive or negative. Does everybody understand where I'm getting the positive and negatives from? Just plugging it in. I don't care about the number. That's negative 17. But I don't care about the number. It's negative. What's negative 20 plus 16? What's a negative over a negative? Okay, it's a positive. Okay? With that being said, here is what the graph would look like. So from here all the way to infinity, what is it always going to be? Positive. So I grab this and I go, remember we did cross at 3/16, and then like I said, it'll approach the asymptote, won't it? Does that make sense to everybody? Could it cross that asymptote? Sure. Do I know if it does? Do I care? All I know is that it approaches it. Okay, these are kind of hard sometimes to find the range though. Okay, because sometimes it does cross it and you can't see it. Okay, does that make sense? Yes, no? Alright, so how about in between this section right here? From here to there, what do we know about it? Negative. And what do we also know about an asymptote? It'll get close to it, won't it? So therefore this graph will cross here and get close to that guy. Will he ever cross that vertical asymptote though? He won't. It is. Did we ever have a negative up there? So how is that kind of hard? We didn't see it that way because it's not in that traditional blunt something over a x minus h plus whatever, right? It's not in that same form. You see what I'm trying to say by that? Okay, so that's why this chart helps us graph. Okay, and then the last part, from here to a negative infinity, what does it need to be? It needs to be positive. Doesn't it say that it's positive over there? So therefore, am I going to be down here? Why would I not be down here? Somebody let me explain. Ready? Why would I not be down here? Because I have to approach this asymptote. If I approach that asymptote when I cross the x-axis, does that make sense? Then notice that would make me negative somewhere, right? Does it ever cross the x-axis down here? But I do know it has to approach this asymptote, and in the end, approach this asymptote. Does that make sense what I'm trying to say by that? So therefore, it approaches this asymptote. If you would like to plug that into your calculator today, go ahead and try it. Your window needs to be at least tell negative 20 to 20 or something of that sort. Go ahead and try it. Yours just a white board. Let's see. I picked a number greater than -4, I plugged it in, and I got a positive, because 1's positive over a positive, correct? Let's pick a number between 4 and -4. 0's a nice one. 1 positive. 0 minus 4. Negative. 0 plus 4. Positive, so I have a positive, negative, positive. What does that come out to be? Does everybody understand where I'm getting these from? Okay, negative. All I care about is positive or negative because I'm asking you to sketch the graph. Okay? Now I pick a number less than -4. -8. 1, positive. -8 minus 4 is negative. -8 plus 4 is negative. So I have a positive, negative, negative, which comes out to be positive. Abby, you okay? Okay? So therefore, this section, anything greater than 4, what's it going to be? Positive. So therefore, it's up in this quadrant, isn't it? So therefore, I approach this asymptote and that asymptote. Make sense? Okay, anywhere in between here, what is this going to be? Negative, so it has to approach this asymptote. Like that. It has to come back down because he's always going to be negative in between there. You see that? Because I have to approach those asymptotes, don't I? Does that make sense? And I can't, he never became positive, so I can't come up here and go like this, because he doesn't ever get positive in between here. That's what that thing's telling me. So I come up, I don't know where I'm crossing, and I just know I have to come back down because I have to approach the asymptote. From here on, what is it going to be? Positive, so am I up or down? Up, so therefore, like that. That's what that graph looks like. So what are my vertical asymptotes? 4 and -4. So x cannot be those things. If I ask you for your domain, what would it be? You okay? Getting a little tired? Okay. Domain would be what? -infinity up to -4. Stop. -4 to 4, because then we're not using things in between there. Right? And then 4 to infinity. Obviously with unions in between. Notice I'm not usually going to do domains with these guys. I mean the ranges, because we're just sketching them. Okay? Does that make sense? Okay? Okay. I think that's a good one. We'll stop here. If you guys remind me, we're on page 9, okay? Now,